fine because Mac has also equivalent repositories. But let me quickly go through it, and if you haven't received the file, I'll send it again. Let me share my screen. Okay, I'm already sharing it.
Yeah, you're already sharing it.
Yeah. So let us go through the prerequisites here. Yeah, the book you can refer is that Hadoop Definitive Guide. That is like Bible for the Hadoop discussions. Most of the topics are based on it. That's a kind of reference book.
Link open.
And this is a good book for the certification as well if you want to pursue that.
Okay.
And this just I mentioned it as a kind of complexity. If you want to gauge the Hadoop and its ecosystem things, just to give an idea of these things.
Okay.
But here is what you should download it. These are the data sets. We will be dealing with that. Plain straight link is there. So the recommendation is that at least you should have 1.7 version of JDK.
Okay.
In the maybe I'll write it here. They should be in your local PC.
Yeah, but that is for Windows,
MacBook
right?
or Windows or Mac, whichever is applicable. So local PC. Maybe I'll put that thing.
Okay.
So everything is local PC currently will do, but I'm going to put it, I think, local PC. 1.7 JDK, this is straight link out there. Just download that, keep it in a separate folder. Similarly, download the VM player, straight link out there. Go there, you will get a download option there. Download it. This is the one you're seeing it here. This is the outer interface. Let me come out from it. You will come to know. Let me shut down the VM. I'm shutting down this VM player, so it will come to know. So the shell you're seeing it here. This is the VMware VM player. Right. Third one you need is the PuTTY. I think you'll be familiar if you are working with Unix or Linux environments.
Yeah.
This is the terminal tool to connect the Unix systems.
Yeah.
Right? So we would be logging into the Unix system through SSH protocol.
Yeah.
And the fourth one you need is the VM. So how it look like is that if you open if you install the VM player here, so these options you don't see it here. So once you have downloaded the VM player like this, so let me quickly go through and tell you how it look like. Let me complete the list and I'll go through that, how to do. So till this point it's pretty straightforward, just keep download it and keep it ready. And then you have download the big guy. This is a quite big, close to 4 GB.
Oh wow.
Because this is a virtual machine, but to run the virtual machine you need a software like VMware player.
Okay.
And then to work with MapReduce code, you need Eclipse. And this also you need to, you could take any version, but Indigo is a quite older one. And so it would have compatibility with much of the Hadoop libraries. So I would go for an older one rather than latest one struggling with incompatibilities.
Okay.
So this is straight link. You just download it and keep it ready, like somewhere. So once you have downloaded it, and once you have downloaded these two, then there's a little configuration required to connect or have the Eclipse ready for the MapReduce coding. I'll also explain it in a minute. And then you would need a WinSAP tool. I think you would be familiar if you work with SFTP or SSH. This tool connect you to any SFTP protocol or SSH basic protocol. So
yes.
In our environment, we might have to transfer files from our local machine to Hadoop, vice versa.
Right.
So there are commands out there to deal with that. Initially, you run the commands to get to know them, but once you have repeatedly, you might have to do it again and again. So for learning sake, you do it 1 or 2 times, but later on, and why do I necessarily waste time in running the commands when tools are already there? So that is the case. So let me show you. This part you need some guidance. So I'm going to show you right now. Let me take a first 30 minutes today to set up our environments. Okay. So once you download the VM player, just install it. You get a VM player like this. You don't see these options. These are all options you have configured it. I have configured it. So this would be blank. Home only there. You see these options. These virtual machines, I have these many virtual machines in my local machine. So I have virtual machine from Hortonworks, Ubuntu, the vanilla Hadoop I have MapR company VM is there, and I have another CentOS minimum Linux machine is there.
We need
So
all
this is
four
my
for Hadoop setup?
no, we don't require all. I just telling you an example.
Okay.
You only working with sandbox, Hadoop sandbox. The
CentOS
Hortonworks.
is a NAS thing, right?
Which one?
CentOS.
No. Nothing is like that. Everything is standalone VM only. Nothing is like that. See, these are all my. If you look at the installation of my, let me see. This is the folder. I'm just dumping the things. So each one deciding as a folder here. So the virtual machine you see the Hortonworks. Let us see. It is occupying 26 GB here.
Oh my God.
So underneath the virtual machine, the VM player manages the disk, the format of the files. So this this VMDK is there. This is virtual machine disk.
Okay.
This itself is a, see how much it is.
26 GB.
27 GB, close to that. Something like that. It manages it. So what you have to do at the most is that download the VM. So let me show you how to download it. Just I'll take a pause. I'll look at the file I have downloaded. Let me pause the screen. Yeah. No, yeah, it is there. So I have downloaded the software sometime back. So you could see it here. This is a 4.9, close to 5 GB. This file you would get from the link I've sent it to you, 4.69 GB, right? So what you do essentially, yeah. So once you have downloaded, let me create a new one for you. I'll clear. So you could choose any place, but you need to be sure that you have good amount of space in your hard disk. If you are working with Mac OS, be sure that you have uh, extra place to grow.
Sure.
So in this drive, I have additional 100 GB. So I'm taking this one rather than I have additional 80 GB. So I'm taking this one. So in the virtual machine, create a new directory. Let's say, since I already have Autumn, let me put a different name.
So first of all, we have to download virtual machines, and that folder will be created, right?
Yeah.
Oh, I
So
don't know how it
this
will happen in Mac.
means can't you download it from the? Okay, let me go to the link and show you that.
Yeah.
See, go to this link.
First, you said you have to download Java Jdk, right?
Yeah. Okay, you want it from the beginning? Let me do it. See, you will have everything. Let me try that first. Okay, before even go to the exe, there would be a separate. Okay, if the link fails, the other option is that go to the extent of. because Oracle might be keep changing the version path there.
Yeah, looks like
So,
Java JDK 8 is there for Mac.
oh, is it? That should be fine. That's not a problem at all. Now I just given no. See, basically, we are basically trying to download the 7.75 version. That's not the hard and fast here. At some time, when we are taking up the second batch, we upgrade to this JDK. But whatever is current in your machine, you could choose that. That's not a problem at all.
Okay.
Okay. So this I think should work. Okay. So they want to change the path. That's not a big thing. We'll go to that. Okay. Even that doesn't work. Let us quickly.
Actually, I did until oracle.com and that thing worked, and then I searched there.
Yeah. That also you can do. See, same thing. Basically, we're trying to download that version. It doesn't then, and we'll get to that. Yeah. The 7.6 is there. That's the reason we're getting it here. We are trying to get the 7.5. So on the same. So you could get that, or you can search it in the 7U
I just did JDK.
7 JDK. That also you can do. There could be so many versions. You could choose anything. There's not a primary thing here. Basically, it looks up sign in here. That is the reason it fails. Otherwise, that link directly would have gone there. Okay, so so download the JDK relevant version to you. So in my PC, I have Java version. I have 7.1. You can even choose to have 7.5, whichever is applicable to you. Once you log into that Oracle OTP, then single sign-on is required. Create your login, and then this link will work. No need to change anything here. Second thing is that the VM player. Let us see what support you have here. Okay. So now you could choose to have VM player in Windows and Linux. You don't have it in Mac. Okay. I'm not sure because
Let me search. VM player for Mac.
MacBook, right? You're using?
Yeah. I think it is there. Oh, this one we have to buy?
We don't need to. This is all freeware. The Windows thing would have compatibility with Mac. I think so. Could you please check that one if that is compatibility or not?
Yeah, I'm looking.
Maybe you can look it offline. If you don't have, we have to figure out some other way.
Okay.
I'll also look into that.
Okay.
Okay, if that is the case, so let us say you have it. Assume for a minute.
Yeah.
Then you need this putty tool, simple tool. Just go through this putty tool. Just download it. You could download the either installation package or the zip file. Zip is a better one. Download that one. You can unzip it.
Yeah.
Then this is the Hortonworks VM. All right. Okay. So you could choose the whichever the latest there. See, currently earlier we were trying with 2.2. So you could choose the 2.2.4. Some subversion has come. It has Spark as well, Ambari. Okay. So this version you can choose it. So download for virtual but VMware. See this one, where Mac and VMware like this. So go into the virtual box.
Yeah.
And then no, I think you have to choose here VMware Mac.
2.
Yeah, this is the one.
2.24.
2.24. Choose any the latest version you have.
Okay, I'll download 2.24 then.
Yeah. So Windows go this one. You have to choose
Yeah.
you have to choose this one, VMware. VirtualBox is for the Oracle based VMs. So these two are different things.
So which
VirtualBox
one
would
should I use?
look like this. So I'll show you what is VirtualBox here. I should have VirtualBox here. Just a minute. 1 second. Where is my VirtualBox? Yeah, this is the one. You see this one, Oracle VirtualBox?
Yeah.
VirtualBox is from the Oracle. They are offering their VirtualBox, but VM player from the VMware organization. So choose that one, whichever. So you have to choose the VMware based VM, not the VirtualBox VM.
Oh, okay.
Right?
Okay.
Okay. So once that is done,
But if VM player is not there for Mac, then I have to choose VirtualBox, right?
see there is a PDF out there. Why don't you open it and see? There is a guidelines also out there. You see this one, VMware Mac for Mac.
Right.
So go through there would be some option here.
Yeah, I'll download that VMware thing now.
Yeah, there will be some documentation out there how to install I think you need to go for VMware Fusion or which is applicable to you for the Mac, because I haven't tried in Mac so far.
Okay.
Maybe this is all Mac related thing or stuff, right? You're saying it here.
Yeah. All this is Mac.
Yeah. So just go through it. There should be a way. Okay. Because I never had any first-hand experience on the Mac.
Okay.
Okay. So this is the one. So once you have it, just go through this PDF. It should be possible. Then the final thing you have downloaded is Eclipse. Yeah. One more thing, Eclipse.
Okay.
Yeah. So Eclipse, go for the either Windows or Mac, both are there. So just go for it, the relevant version. Don't choose the Linux one because we are trying to work with Eclipse on the Windows PC. It will be familiar rather than trying the unknown thing. Okay. And finally, and you need to do little setup once you download it, and let me know once you download tomorrow. Then I'll explain you how to set up the Eclipse. A small setup is required. Will do. And finally, you would need to download a small tool called WinSCP. This tool would look like this. This is a WinSCP tool whereby you connect to any virtual machine host like this. If I am having a host like this, you will connect it. Yeah. Before that, I was talking about I want to show you how I'm connecting to Sandbox here. So you remember I've created a new folder in my location where I have a space. Practice Horton. Okay. So I have a folder like this. So before that, I have downloaded the Hortonworks VM from the same location, what we have seen here. Right, similar thing. I've downloaded this version rather than the 2.24. That time it was not there. So this one I have VMware 4.7 GB. That version I have. So now I'm trying to configure it. So how do you do? Open a virtual machine and look for the options here. See, you see OVA file, open virtual machine format file, OVA file. Then mine is a OVA file. Same thing, right? Just copy this thing, put this and choose the Hortonworks file. Now here you have to configure it, where you have to store this VM, because this is like a zip. So this VM player will extract this whole thing, like the one you're seeing it here. It would extract this OVA file into the VM DK files. So it has its own structure to manage the VM. So now we have to tell them what is the structure, where we have to dump it. So I've already created a folder like this. So this path, copy it and replace here. For the clarity's sake, you could choose Hadoop class, something like that. Yeah.
I have virtual machine for Teradata, so I have to install separately for virtual machine for big data.
Not required. So you have VM player in your machine or workstation?
Workstation.
Yeah. Should be fine. That should be fine. Workstation is higher version of VM player.
Oh, okay. So I can.
VM player is a basic version in the VMware offerings. If you have already workstation, that should be fine. That would also have similar options. Go to choose the like this. Open a virtual machine option somewhere in the virtual workstation. In the same workstation, you could have this one also.
I have power on this virtual machine. It's starting.
Okay, so I'm giving a name to this virtual machine. Then I'm saying this path is the import path. Are you all with me, or shall I?
Yeah, I'm just opening it.
Okay.
This you said you will show this configuration after we download again, right?
Oh, you want me to do that time? Not now. I can do that.
Because I mean we don't have the softwares yet. I mean we didn't download all this stuff yet.
Yeah.
Oh, no issue.
Again, it
no
will.
issues, sir.
You will be telling and we'll forget. So that time we have so many doubts. We'll do it simultaneously.
Yeah, that's what I wanted to do simultaneously.
Not a problem.
Yeah, we both will do simultaneously tomorrow.
Okay.
Is it okay, Raj?
Yeah, that's fine for me.
Okay, then tomorrow we'll do it.
Okay, so you're clear about this download links, right?
Yes.
Even if you don't get the exact version of JDK, no issues. Choose whatever is available. This is not hindrance at all. No, I just put it for some version. No big deal there. Okay. So this is one thing. So I'm trying to close these tools. So yeah. So I'm running the Hortonworks VM.
Okay.
So today what I would like to cover is that the material. Are you familiar with the Linux and Java syntaxes?
Linux is like Unix stuff?
Unix.
No, Madhu.
Okay. You aren't familiar, Sharada?
No, don't do.
Okay. So I have one simple Linux commands file. They should give basic understanding about the Linux files, If you get into the Linux here, this is Linux VM, right?
Okay.
So I'll be sending these files to you, right, soon after the class. So just go through the files, and once you have VM tomorrow, maybe that time it will be relevant to you. I'll run these simple commands for 5 minutes, and rest of all you can take it on your own. So the simple commands, how you do in Windows, listing commands, copy files, moving files, deleting
These,
files.
these are the things which are like short. These are the abbreviations.
No, they are the commands.
Okay.
This is the command. This is a command, and this is the meaning of the command.
Okay.
CP is the command, and this is the meaning of the file. CP for the copy,
Okay.
like this. So for file directory basics and for the file viewing basic, to open a file, cat and a file name.
Okay.
And less will give you paged approach. Head will give you the first few part of the first number of lines, say 2 lines, 3 lines of a file. Tile
Oh.
will show you the ending of the line. These things you might not have seen in the Windows environment, but Linux is pretty good at this the file handling level.
Okay.
I mean to say Unix and Linux both are very good, tremendously good. And many more sophisticated commands are there to look at the files. So the reason I'm saying these things is that when you're discussing about HDFS and we want to try out HDFS command, these are all nothing but same commands will work in HDFS as well.
Okay.
Most of the commands, except one or two exceptions. Most of the commands as easily with their as is behavior work in the HDFS. So ultimately, after all, HDFS is like a wrapper on top of the Linux-based system.
Okay.
So same commands will work. So if you want to get hands-on with HDFS, you need to try practicing these commands. At least, if not all, at least the initial commands. At least these set of files, first few, sufficient for you. Even at time permits, you can try the file viewing. Because in the HDFS, what you do, either you put a file, you insert a file, remove a file, view a file, right?
Yeah.
That's what you do with the file system. At least the initial 5 commands you should do it, try it.
Okay.
Okay. So those things. So once your environment is ready, we'll take some time and go through it.
Do you have similar commands for Java as well?
Yeah, I have not commands, some refresher about it. Let us take a moment here.
Because I don't know about Sharada, but I have zero knowledge in Java.
Even I don't have any knowledge.
Okay. So why don't we go through it now before we take the further things, So let me quickly, I'll touch upon the Java part. I'll give a high level overview. You would need little Java skills when you're dealing with the MapReduce code, right?
Okay.
So let us quickly go through it. So Java is a platform, a platform independent program, but itself is a platform. It is supporting many other frameworks on top of it. Hadoop is one of that. And it looked like C++ syntax, the definition part. So let us not worry about these things. Let us look at the construct part of it, how Java is going to work and what the construct for the Java. These are all the jargons about it. If you are there in .NET world, Perl world, or if you are there in PHP, you see much of the same thing. Any programming language, and nowadays modern language, is supporting all these things. So what is going to happen in Java? So we write source code in Java file, .java file, and once we compile it. So typically what compiler we have, Java is a compiler, Java C is a program that compiles the code. So if you are working in Eclipse, Eclipse is studio
for Java,
studio editor for the Java code. So that studio already would have Java C compiler. So compiler you get it like this. So once you deploy the JDK, let me go to the path I have. Java here. So you have many versions here. So once you have downloaded the version here, so in the bin you see many Java programs here, right? So there you see Java C. This is the compiler. This comes along with your Java JDK setup.
Okay.
And java.exe. This is the Java VM, virtual machine. These two are the essential files. So we don't need to worry about these things. If you download the JDK and set it up, these things are all provided, rest assured. So in the Eclipse, once you've written a code and then compile it, it looks at the Java C program and compiles it. That's all pretty much automated. So the output of the compilation is that we get a file like .class. So the .java file would have been converted into the .class file. So what would happen in this transformation is that .java file is your human readable file. It's a text file. It has Java syntax. You start classes, inheritance, encapsulation, all the things you follow there. No, all the OOP based things. And Java would have classes to much of the activities there. So this is human readable file. But once you compile the file, that would come down into the bytecode, machine code file. But this is not like a self-executable file. If you look at exe in our Windows PC or Mac, those are all self-executables. But Java Java bytecode file, this is not self-executable file, though it's a machine code file. This is intermediate file, basically. It needs JVM to run the file.
Okay.
And then there is Java program out there. It takes care of running the file. But you don't run the .class files as easily. You compile so once you compile everything, you get a jar. Jar is like a collection of these classes, Java classes, into a zip file called jar, JAR. You would be hearing the file jar again and again.
Yeah.
So that jar is executable one. That jar is executed through the JVM.
Okay.
So what would happen is that, so once you prepare a jar here, this jar will be executed by the JVM thing, runtime thing. This is the runtime part. This is all the coding part. This is your code environment, your development environment. And this you are moving into runtime environment. See the one I did it before. So when I hit the Java, it says this command would have invoked the program called Java program here. Java here. So I could choose to have versions for it. No? So it tells me the version. So same thing you are seeing it here, same version. So it is pointing it to Java. So what would happen here is that when you're deploying the Java, your system environment setting would have already corrected that Java home automatically. Not this one. Could choose that one. No, I'll show you tomorrow. Other things setting is there.
This is a little. I think it's getting a little complicated.
Okay, and let's not worry about too many things at the same. So once you deploy Java, this Java program would have been recognized it. So the soon you hit Java, system will understand where Java is there. Those things it will recognize it. So what would happen in this case is that when you compile the Java thing, the output is like a jar file. That is like jar file. Jar is what is a collection of your Java classes. So typically the concept here is that when you write a code, Java code, you don't write a single class, right? You would do multiple classes. You write multiple classes to develop it, right? Typically.
Yeah.
So let us say even you write a small program also, you may start with the main program. That main program invokes other class, all the OOP stuff you follow it. So you can't run class by class. You have to compile all class together, put that in a zip file like that. So jar is like a zip file for the Java programs. So the Java program can understand the jar structure and will run it. So what will happen is that typically when you write a code, Java code, what you do, you either make a network connections, you read a file, you do some screen display, something you do. For each of the activity, Java would have a default libraries. That's called class loaders. So supporting DLLs, right? DLL are jar files. If you are from Windows background, that's all DLLs. If you are from Java background, that's all jar files.
Jar files.
That's as simple as that. And then once the required files are identified, now the JVM, the Java, will interpret the file that can able to understand the jar and inside classes in the jar. Now that executes the main program there. That's called just-in-time compiler. It compiles the intermediate language to the actual machine code. The difference you see from C and Java is that when you write a code in C and compile it, the C program would be converted into the actual machine code that can be understood by the native operating system like Windows or Linux or the Mac. But if you look at the architectures, Linux architecture is different from Windows and Mac. So how can a C program compiled in Windows can run in Mac? It can't. That is the complexity in C programming. So if you want to run your C code in Mac, you have to compile with Mac compiler and run there. Similarly, if you want to Mac and Linux, right? Each one has a set of compilers. So if the program running in Windows, I'm talking about C program. The C program that is running in Windows, it can't run directly in Mac. You have to recompile in Mac and run it. You have to recompile in Linux, you have to run it. That complexity was there. And there could be some dissimilarities between the versions, so that all things are there. Because of the reason, Java world came with a concept called JVM. So in each of the machines, we have JVMs. That JVM is very specific here. Windows JVM, Mac JVM, and Linux JVM. Okay. But the code you write in Java is unique. You don't change the code from machine to machine.
So just change the JVM and you should be good.
Exactly. So that the translation part is taken care of by the JVM part. You only worry about understanding Java syntax and writing code. So that is the universalism Java brought in.
Okay.
You getting the point here?
Yeah.
Okay, so now you don't worry about whether you're writing code for the Windows machine or Linux machine like that. You worry about Java syntax only.
Right.
But the JVM changes between the machines, right? So the rest of things are pretty common. The JVM can interpret your code and then it executes it. Okay?
Yeah.
So that's all about the Java part of it. Okay. So this is Java architecture. We just looked at it. So how it works, that's what we discussed it. Java security is all okay. All the OOP, object-oriented design also comes into picture. It is portable. The reason you see this word again and again, the word is a portability. The reason is that you're writing a code at once, and that code works everywhere. This is some 20 years back. These are the concepts.
So is there an example Java code that you use in Hadoop? Do you have something as an example?
We do. The one we're talking about, MapReduce, that framework is in Java. So you have to develop a small Java program and run it. I'll show that in the next subsequent classes.
Okay.
So today we are discussing only about the
setup.
Yeah.
Okay. So I got Eclipse finally. You said there was some setup, right, for Eclipse? Or do you want to wait until both
tomorrow
of us get it? Okay.
So there are some primitives in Java. Primitives in the sense they're integer, float, double, those things.
Right.
The language construct here. So these are all pretty much same. In any programming language you take, pretty much same. Even the concepts are much of the concepts you see from you see from the C world, C++ world. So variable assignment happens through equal to sign and the semicolon is there. So these are all flow statements, looping statements for while, do while, control statements like if else, switch case are there. Escaping characters are like break, continue, return. These will control the for loop, while loop, do while loop, like that.
Okay.
Don't worry about these things too much at this point of time. This is pretty common to any programming language. If you are from if you have done any programming exercise, you would get it. But if you not done anything so far in programming, you're completely in the either in analyst side or something at the data warehousing side. Don't worry also. You'll get to know. You don't need to really boggle your head in this. No, oh, I need to learn all these things. No need to. I'm just showing it to you, just to get awareness about it.
Okay.
This is about nested if like that. I'll send this document to you. Just glance at a high level. Don't need to worry about anything. No.
Okay.
It is comprehensive for the Java beginners, but you don't need to learn everything at this point of time. Even I don't really recommend you to be master of MapReduce. It is sufficient to know that such thing exists and you can do it. But I would really recommend you to focus more on the Hive, Pig, those things.
Hive is the one with Unix, right?
Hive is the one that is a querying language. And the
query, okay.
Okay, so I'm just closing it because if you are from these backgrounds, you'll find interesting. Otherwise, it'll be boring to you. Let us not waste time in these things.
More than boring, it is terrifying.
Okay, but I would request you to go to the Linux command. This is needed for you to do some practice.
Yeah, I am from a Linux background only.
Okay. For Sharda, I would strongly recommend you to go to these commands, at least the first set of commands. File directory based basics. Just go to this list of 10 commands here. That should be sufficient initially. Okay. And then moving on to the okay, so we have touched these things. Then okay. The Hadoop intro, let me see if we have not covered anything in that. Cover it. So the history part we have seen it, the background about it. So some definitions we have seen it. Some high-level comparisons also we have seen it. Okay, let us move on to the Hadoop use cases before we start discussions. Yeah, just to recap our discussion on the Hadoop. So the core components in Hadoop are Hadoop file system and MapReduce. These two are the core components in the, core frameworks in the Hadoop. And other grayed out ones are the abstractions built on top of these core. So today and tomorrow or in next 3 days, we'll discuss more about these two. And you should have thorough understanding about these things before we start looking at Pig and Hive. So let us look at the use cases where Hadoop is going to pitch in. Is it a kind of a replacement of warehousing thing or like? So this slide will give you an idea. This is not a replacement, but moreover it's a kind of complementary and even contribute more to the warehousing power. So in a sense that warehouse are pretty much structured wells, you can't deal with unstructured data or no structured data. But Hadoop is good at these things. So if you ever looked at warehouse, you could not imagine warehouse be dealing with sensor data, all the non-structured data, semi-structured data. It could not have been happened at the warehouse. But if that is the organization requirements, you have to deal with this unstructured data or semi-structured data. Hadoop is a good winner in that. Hadoop can take up these unstructured data files, have them in the Hadoop, and using the Hive and Pig kind of tools, frameworks, it can transform the formats and bring down a decent structure, and then finally push it to the warehousing thing. And pretty much many organizations would have a legacy warehouses. They would have sophisticated reporting system on top of the warehouses thing. So this is all pretty much standard. No need to spend extra investment in these areas. Already it has been stabilized.
Do you know how long it takes for a query to run to like extract data from a big file?
You mean the sources? You mean to say?
Yeah, like example, you said there are like over terabytes of files, right? Big terabytes of files.
Yeah, yeah.
If in Hive, I think, right? That is a query language.
Mm-hmm.
If you query something on a 1 terabyte file, how long is the results going to take to come back?
It takes a while. I can't tell exactly how much time it takes. It depends on the kind of querying you do.
Okay.
If you are doing very intricate aggregations on top of it, it might take some time.
Okay.
But if simply doing a simple simple querying, it will be pretty fast.
Okay.
It will be instant almost. That's how it is. That we'll cover it. I'll show some demos in this area. But basically, we're not talking about the responsiveness of the system here. Please understand that part.
Yeah.
You're not trying to, let us say I have a 2 terabytes of file, how fast Hadoop can retrieve that. That's not the real objective of Hadoop. Hadoop basically to transform the one structure to other structure. The structure, the initial structure is kind of a not completely standard one. That's what you're trying to say in this slide here. You are trying to look at a not organized data, not well-formed data, that you're taking it and doing some transformation here and then pushing it to warehousing. So the question of whether we can retrieve 1 terabyte data quickly, obviously we can't do that efficiently what you do in DB. But that's not the objective of the Hadoop. You know, we are trying to process the 1 terabyte file as much as possible, as quickly as possible, and then bring it to a standardization format.
Okay, now it makes sense.
That's what the use case here.
Okay. So company can have terabyte of file frequently, right? I mean, they can have 1 terabyte of file on a daily basis.
Daily they can have. Daily they can have.
Okay.
Each day they can have, and Hadoop can take it up the terabyte file. It can process the file in 1 hour and then push it to warehouse. That they could have.
Okay. Yeah, that means we are transferring unstructured data to the structured data, and we are storing a data warehouse.
Yeah, this is one of the use case. This basically, this is not the only way to do, but this is the way. See, let us say, why do people invest in new technology unless they see value?
Yeah.
Right. The executives, why do they invest so many millions in this in new technology stack? The value they see is that nowadays the emergence of all the social media and various kinds of formats we have seen earlier in demo classes. We have so much of instruments now, right? They're producing wide variety of formats, and the earlier warehouse are not meant to do all this processing. They're only good at this table-based approach, right? You have a table have join, those things it is good at it. Yeah. It is never designed to be dealing with sensor data, which has very loose structure. So, but today world, people need the data to get some analytics on top of it, or bring down the cost of their infrastructure monitoring. Many reasons could be there why they want to pursue the logging data, the sensor data, the blogging data. Each one has their own meaning, right? They want to get more intelligence into what is going on around. So in that case, you have to deal with the loosely coupled data, right? Loose structured data. That time they can't do directly here, and though they're tools, but if you look at the volumes, they're unable to do. Each day we are producing 1 terabyte of file, and very soon in 1 month you have 30 terabytes of file. So without Hadoop, the choices are you write a Java program or some other Linux program, but that itself takes so much of time. To process 1 terabyte file in traditional programming, it takes almost a week, right? So you can't afford to have that much time. So you need a higher, different program, different platform to deal with the volumes, not just the variety. Now we have variety, but also we have so much of volume. Remember the 3V I have showed you: volume, variety, and velocity.
Yes.
Because of that driving factors, this system is existing today. Otherwise, Hadoop need not to be there. Only the variety is there. There is no volume. Then you could do with the Java program. Why do you need all this big Jing bank here? Nothing. No, not required. Right? Let us say because of velocity also at a high, tremendous speed, so many formats are coming up, and so much data being produced, right?
Yeah.
So because of reasons only this framework is existing today, and so with that background, it is very obvious that we need to have a very efficient and quicker platform to process the file and bring it to a format or a shape so that this can consume it, right?
Yes.
So this is one of the use case in the Hadoop world. Second use case you see, it's also in the data. It's also in the data area. It's a kind of complementary for the existing line of businesses. So today, it also talks about the same sources like weblogs, emails, sensors, social medias. But today, let us say, organization wanted to build a monitoring system on top of all these sources. They could do to some extent in these traditional systems. They can have Oracle database to dump all the logs. They could have SQL Server to dump all the logs. But look at the cost involved in that. Oracle and SQL Server, MySQL database are expensive in terms, not just for licensing, in terms of the hardware they need, in terms of human resources they need to manage them, right? They need a separate data center, they need fault tolerance systems, they need a different the data center for disaster recovery. Many things are involved in that, not just the technology part alone. So per GB in RDBMS is much higher than per GB in Hadoop, the cost to maintain it. So the executives are looking at a low cost solution yet powerful. So in this case, they would like to build a repository in the Hadoop just to handle the low significant data. This is not the transactional data. This is the transactional data. The organization would have a website or any. Imagine, take example of Amazon. Amazon would have their website that is the main bread and butter of the organization. That have many systems to support it. They are structured ones. But Amazon would be parallelly tracking down user, what they are buying, what their choices. Those are all like intelligence. They would collect it, but that's not transaction data. That data they would pump into they would call as news sources, right? Okay. The logging data, web logging data, the censored data, something like that. So but that data, though that's not a transactional data, but somebody can able to analyze the data that gives a business meaning, so that they can tune their business offerings. They can give much more customer-centric prioritization. That they can do. So it's not very relevant for day-to-day activities, but at a higher realm, they have tremendous meaning that add value to the organization business. So the organization don't want to lose that kind of intelligence. They want to gather all this data, and using Hadoop, they can enrich the data and bring some data into some tabular format, so that the operations guy, the business analyst guy, they can use it and then bring reports on top of it, something like that. Or let us say some features are not working in the website. How do they get to know? The logs would be sending data to the web servers, right? That feature is not working. So you could deploy some monitoring applications on top of the web logs. Not on the raw data, Hadoop would do some transformation on the web logs. So on the transformed data, you could deploy some monitoring tools that can detect the issues in that web application like that. So this is like an infrastructural intelligence building using Hadoop.
Yeah.
This is a different use case, the one you see earlier. This is like complementary in the warehousing thing. This is, we're not pushing data to anywhere. We are basically enriching the operational intelligence here.
Yeah.
And third use case is, this is also kind of complementary for the line of businesses. Let us see how it is going to work. So this is existing setup in the postal department, the power generation department. Each time, typically I think this use case from the US origin, I think. So in the US, the power distribution companies, they send their staff to the individual homes to collect the meter reading. And the handheld devices, they record the meter reading, and the handheld devices would have connectivity. They push it to the ETL system, and then finally they get into the warehouse there. And from that they consume it in many formats in many ways. This is the existing setup without Hadoop. But they felt that in all these areas, having human resources to collect the meter reading is becoming a most costly affair. So they want to cut it down, and also cutting down the expense on it. Then they decided to collect the data once in quarter rather than every month. That time they can pay less amount to the staff, right? For each visit they have to pay some amount, so they reduced it to once in 3 months. So in that time, if you look at the existing architecture, what would happen is that once in 3 months, tremendous volume would flow to the basic ETL systems here. Nowadays, let us say in every month, all the staff would be pumping 1 billion meter readings. Not 1 billion, of course, US population not like that. The 10 million population. So all the staff would be pumping the 10 million readings into the ETL system. But with the new change in the staffing model, every quarter they would pump 30 million meter readings to the ETL system, right? So this huge volume, system cannot scale up, or they need to put more investments here to scale up the system. So either way, initially they thought of cutting down the staff bills, but they need to put more investments on the ETL system. So this is the kind of either way they're not seeing much value in. So let us see how Hadoop can bring value in these kind of systems. Now they completely cut off the manual staff there. They deployed all the sensors, smart meters. That sensors would have connectivity. They pump data to Hadoop centralized system here. That's all sensor data, you mean to say. This is what we are discussing.
So every house will have that?
Smart meter.
Yeah, every house can have that, right?
Yeah. Every house can. I don't know whether you have there or not, but that's what the use case it is showcased. Okay. So I think this is in practice in US in many areas.
Yeah.
It is there, Raju.
I know, it is there.
When you have any problem, they will give like this many months your reading is like that.
I know.
Yeah.
In all houses it will be there mostly.
Yeah.
Okay. So in that case, so sensors would pump data into the Hadoop centralized system. So it doesn't matter you have 1 million or 10 million. Hadoop can able to scale up that throughput. It is meant to be. It can take so much of sensor data because it's distributed file system. It can cope up the huge loads it is taking up, and then in each month cycle, there would be a process that runs on Hadoop and that transforms the sensor data into the consumable ETL data, and then things goes on. This is the old style only. If you look at the document, this one, we didn't change the existing architecture here. Only the refinement happened in this area. Instead of the staff, the Hadoop brought down Hadoop implemented the smart meters there. So with this, organizations can see value. They don't have to put more investments here in this already running systems. Hadoop is comparatively cost effective in terms of human staffing, in terms of expanding these basic ETL things, because traditional systems are more costlier than the Hadoop infrastructure. That is one of the game changer in the Hadoop. Hadoop comes with power at a low cost.
Yeah.
So that is one of the reasons. So that is it about one of the use case. And finally, how Hadoop is bringing value in the analytics world. So so now we have seen Hadoop. We have analytics are there for a while in the RDBMS systems. They do the dimensionality cubing part, and then they reduce to various schemas, like example like star schema. They do it, and then finally they develop reports on top of the schemas, right? So that is this is a pretty familiar world. We have seen it, but Hadoop, having Hadoop there, we can do many things, many possibilities are there. Either we can transform the data, raw data from various formats into the traditional analytics systems, or this itself can transform data and run some of the basic analytics jobs on the raw data things. So in this also, you could see Hadoop is kind of a complementary and bringing value into the existing analytics investments. Right?
Yeah.
So that is about the Hadoop use cases. Yeah, let us see the one more important one. This is just a value propositions. So yeah, the 3V factors we've seen it: velocity, volume, and variety. In these factors, how it is bringing value to the analytics systems. So Hadoop is very good at the variety of data, and analytics systems are very good to deal with data. They're more look at the real-time data. It's called velocity part. As in when the event occurs, they want to update the analytics model. Example, I can quote you. Let us say you're doing a credit card transaction, and typically your average monthly credit card per transaction is like $100. But in a certain case, you have swiped card for a $20,000 for some reason. Okay. That's above beyond your average, daily average or transactional average. That's a kind of alert to the credit card company. They look at the transaction type. Is it a legitimate transaction or some compromise is there? Then they can look at the analytics system. Is it a fraud or is it a genuine? So that with that real time, they should give an alert so that you might get a call from the credit card company, right? Sir, some transaction happened. Are you aware of it? Something like that. So how that could happen? I think have you witnessed this kind of thing?
Yes.
Okay. So how that could have happened? That is because of analytics platform. They would have had a fraud detection system in the analytics framework. It all looks at the real-time events. So any event, they would have a rules engine say that anything that is beyond the average for an event, that event goes to analytics system. The system will detect pushes into the fraud detection system, and then all things will happen. So the point I'm discussing is that comes under the velocity part of it. As in when the event occurs, you should be able to look at it. But Hadoop is good at the variety part of it. But here it is managing for velocity and variety. The analytics system should be efficient if it has a large volumes of corpus, means the use cases or the test data. And Hadoop is good at handling the huge volumes. That's where the Venn diagram, if you look at it, the conjunction you see, it's like Hadoop will give you the power, the volume processing power to the analytics system. That's where the value is coming up in the analytics. All right. Now, yeah, one more last use case. Two more use cases I have. I think we just crossed 10 minutes, but let me complete it for next. Hardly I have 2 slides here. Rest of all the standard ones. Here also, if you look at Hadoop, Hadoop is like, it is bringing value in the analytics-based systems here. Predominantly, it is taking up the unstructured data here or the semi-structured data here and acting like a ETL system here, transforming it to the known formats, and then finally this can be consumed by the analytics systems here. So it could be a complete renovative analytics systems or could be a complementary analytics system.
Can
And
Hadoop import XML files?
could you, I'm barely able to hear, Raju. Could you speak a little louder?
Can Hadoop import XML files also?
Yeah, we can. Anything. See, Hadoop doesn't stop you to import any format. It's a file system. Let us say, yeah, maybe I'll discuss that point tomorrow. That is a good point. We'll discuss that. So this is that slide. So this is one more interesting for you. Are you aware of Aadhaar card in India?
Yes.
Yeah. So in Aadhaar card implementation, it is from the day one they started using Hadoop.
Oh.
How it goes is that look at this part there. So they have various data collection points here. Okay, they have the data collection points here, and now look at it here. In the Hadoop, basically, this is the data collection point here. So the individual operator, they would be carrying laptop, going to remote villages. They don't have the internet access. Of course, internet penetration is very less in India compared to US. So Aadhaar card covered length and breadth of India in all the regions, right? So they would carry a laptop, collect the data, fill up the form, those things they do, and then at offline they do all the things, and they come to online. When they come to the main connectivity point, they push the data into some set of servers. In this case, they use MySQL servers, and then that pushing would take this route here. They go into data mart here, and finally, the data mart, before it going to data mart, look at the transformation it's going to have. It is doing transformation of the data, and then finally it pushing it to the it converting into a structured data sets, and then it is enabling the dashboards on top of it. So here the connection is there. It converts the data into standardization, again pushes back to the data mart, the dimension data marts, and then pushes to the other data marts for consumption. Or the structured data can even be consumed by the dashboarding activity. So this is not a very in-depth utilization of Hadoop, but point to be taken is that look at the tremendous load putting into the servers. They just take it and pushes to Hadoop. They don't do much thing here. This is the route, basically they take it, but these servers are like collecting points, and they don't do much of the transformations there.
Yeah.
So that is the point trying to say.
Okay.
All right, I think we covered. We are I think today's session almost we're there. So tomorrow we'll regroup together, and then we'll start about the HDFS architecture. And yeah, first 20 minutes we'll set up the environments, and then we'll talk about HDFS and MapReduce.
Okay.
Okay.
Yep.
Yeah, please download the softwares, and we'll start the session tomorrow.
Okay.
Okay.
Thank you all.
Okay. Bye.